Again, good evening to all and welcome to Learning Beyond. As a part of our workshop series, today we are going to discuss on loads and load path. This data is required for structural engineers, all of you know, and civil engineers. So as we are dealing with different structures, so we do the analysis design in the office and we also do the construction on site as a civil engineer. So this knowledge is very much important from civil engineers point of view and structural engineers point of view. And in this series, we will start with the gravity loads, which is very important. Gravity loads means dead loads of any structure. And there may be live loads also for in gravity part. Okay. So today we are going to discuss on this. So can anybody tell me why this knowledge is required? Loads and load path. We can have interaction in between. कोई बता सकते हैं loads and load path क्यों चाहिए सीखना? Where it is used, this knowledge?
Every structure we have to firstly define the loads and load.
Can you repeat again, please?
So in every structure we have to firstly define the loads.
Right. So all of you know that any structure means it may be RCC buildings, it may be industrial sheds, that means steel structures, water tanks, retaining walls. There are many structures, bridges and all this. Okay. So such kind of structures, all of you know that they are constructed using some material. So material is there. And all of you know that when there is a material, definitely it will have a weight due to gravity. Right. So weight is nothing but mass into acceleration, all of you know. And that means if this weight is there, then the material should take the load. Or it should take the stresses which are coming in the material due to the loads. Okay. So you know that due to loads, there are different forces like axial forces, compression, tension, or it may be bending moment, shear forces. So all kind of forces are coming in the material or in the members, we can say. So the material may be steel, the material may be RCC, that is concrete. It may be timber. So different materials are there for construction. So whatever material you are using, it will have its weight, self weight, in the direction of the gravity. Okay. And as it is in the direction of gravity, we call it as a gravity loads. Now in gravity loads, there are two types of loads, dead loads and live loads. Okay. So dead loads are generally permanent. That's why we call it as a dead loads. Live loads are flexible, we can say. There may be live load, there may not be live load sometimes. But still the direction is gravity only. So it is in the direction of gravity because live load is also a kind of dead load, but it is moving, let's say. Dead load means why I'm saying dead load, it will have a self weight. That's why it is a dead load, I can say. But it is flexible. It may be there, it may not be there, like furniture or human beings or people who are using the rooms or flats like that. Okay. So this is the overall idea. And many times for structural engineers, this part is not clear because this is very basic or it is very conceptual. Okay. So all of you know that if you don't have the basic knowledge or conceptual knowledge, then you cannot do the advanced part of any engineering. So this is very important, conceptual or classical also, I can say. So that is the reason we are here to discuss on loads and load path. It will be useful for structural engineers and it will be useful for civil engineers also who are working on site. Now, so I will just show you some examples where you will understand. So, and okay, then what is the next part is load path. What do you understand by load path? Load means you understood the weight. Currently, we will discuss only gravity loads. So any material has a weight due to gravity and mass. So mass into acceleration. So mg, let's say, gravitational acceleration. Okay. So this we have understood. That is loads. What is load path? Load path मतलब क्या है?
Understand हो गया? समझ लो. Sir, how the load will transfer?
Load path, yes. So first of all, you should understand the load which is coming, and then you should understand where it is going and in which direction. Okay, so if this is a man standing here, it is having his weight, self weight. So it is going in the gravity direction on the floor. Let's say this is your floor. So this direction shows the load path from where the load is generated and how it is transferred. Okay, now let's see one example. If you see this structure, small structure, there are walls here, and there is a slab resting on the walls. Now tell me what loads are there? What loads you see in this structure?
Slab load, wall loads.
Yes, so slab load means slab weight or slab self weight, right? Why slab is having self weight? Yes.
Because it has certain density.
Because slab is having mass. Yes, it is having some mass and it is having gravitational acceleration also. That's why it is having some weight, like, right? Definitely wall will have a self weight or wall will have dead load, whatever you say, self weight or dead load. Why dead load? Because it is permanent. What loads are there additional? What do you see here? There is a footing here. You can see footing. So footing will also have a self weight. Now tell me, if you want to calculate any weight of any object, how do we calculate the weight of any object? Let's say I have one block like this. Okay. And this block is of concrete. Let's say the height is 1 meter and the length is, let's say, 4 meters. Width is, let's say, 3 meters. And this is a concrete block. So can you tell me? And let's say it is resting on one floor. So what is the weight of this block? How we calculate the weight of any object? Weight matlab kya hai?
Sir, length,
Density
width,
into
height.
volume.
Sir, length, width, height into
Yes, so
density.
self weight will be, yes, so I can say density into volume. Self weight or dead loads. Self weight means it is dead load, or you can say gravity load, whatever. See, these words you should know. We are using since engineering. Density into volume. So generally density we calculate in terms of weight. So weight density you can say. Now tell me what will be the, say, weight of this block. Density concrete का कितना है?
25.
25 kilonewton.
Generally 25 kilonewton per meter cube into volume कितना आएगा इसका? 1 meter into 4 meter into 3 meters, right? Simple. Right? So total weight is in which direction?
Vertical direction.
Vertically downward in the gravity direction, right? So any object having some density will have this self weight in the gravity direction. So this is actually your total weight. Now if I ask you what is the pressure exerted on the floor due to this block? Pressure निकालना है मुझे. Either pressure or you can say stress. ये floor जो है ये, let's say this is your floor where it is resting. So what is the pressure exerted or stress exerted on the floor due to this block load? Tell me.
Stress equal to load upon area.
Yes, so this is your force, self-weight, or we can say load. So load upon area. So load is 300 kilonewton and weight कितना है? Sorry, area कितना है? Where it is exerting the, which
12.
area it is? Yes, so this is the area. So this bottom area, you understand this. So I'm taking deliberately from very basic principles. Huh? Some may miss this. So this is 3 into 4 meter. This is also meter. So it will be 300 divided by 12 kilonewton per meter square. Okay. So this will come some number. So that is the pressure on the floor. So this is the overall, see, means we can say that if you want to calculate the load, you should know the density of material. Okay, so this is very important. And what kind of material we are using in civil structures? क्या material use करते हैं हम? We use concrete. We use steel. Okay. We use bricks or brick wall. We use water also because water has a load. We are not using for construction, but we are using, the load is coming due to water. So can anybody tell me what is the density, or generally we call this as a unit weight of these materials?
It's 1660 kg per m cube. Concrete 2400 kg per m cube. PCC RCC के लिए 2500 kg per m cube.
Hello, can you repeat? For concrete, what is the unit weight?
25 kilonewton per meter.
25 kilonewton per m cube.
Meter cube. So force per volume. Steel
78.5
7850
kilonewton.
kg per meter cube. Brick wall
20 kg per m.
20 kilonewton per meter cube. Water, I'm just taking round, 10 kilonewton per meter cube. Okay, you can convert this in kilonewton. If you want to convert that in kilonewton, क्या आएगा ये?
78.5.
5 kilonewton per meter. That means for calculation of any loads, you should know the density of material, whatever you are using. Okay. Or if there is some external object which is creating the load, then you should know the density of that object. So there may be glass, timber. There are many materials we are dealing with. You will get this data in IS 875. Okay. There is a code where all the data is given. Okay. Part 1, I think, where all the densities are given for different materials. Okay. Now, once you know the density, you can calculate the loads